Welcome to Module 3 of the Cyberstrategics Networking Fundamentals course. So far, we've covered networks and addresses. Now we learn the mental model that ties it all together, the layered models. This is the single most useful framework in all of networking, and I'll make it painless. Here's the core insight. Networking is too complex to handle all at once, so we break it into layers. Each layer has one specific job, does it well, and hands off to the layer above or below. Like an assembly line, no single station has to know everything. This layered thinking is what makes networks understandable and fixable. Here's the plan. Why layers exist and what they buy us. The OSI model with its 7 layers, the classic teaching framework. The TCP/IP model with 4 layers, what the internet actually runs on. And encapsulation, the clever wrapping process that carries your data down and back up. Let's build it. Why go to the trouble of layers? Because it lets each part evolve independently. Your Wi-Fi can get faster without anyone rewriting how websites work. A website doesn't care whether you're on fiber, cable, or 5G. Each layer only talks to its neighbors. This separation is powerful for 3 reasons. It makes networks easier to build, easier to troubleshoot. You can say the problem is at layer 3, and easier to secure, because you can defend each layer with the right tool. Here's the OSI model. 7 layers, from top to bottom. Layer 7, application. The apps you actually use, like your browser. Layer 6, presentation, formatting and encryption. Layer 5, session, starting and stopping conversations. Layer 4, transport, reliable delivery where TCP lives. Layer 3, network, addressing and routing where IP lives. Layer 2, data link, local delivery using MAC addresses. Layer 1, physical, the actual cables and Wi-Fi signals. A classic memory trick, bottom to top. Please do not throw sausage pizza away. You won't memorize their jobs today. Just know the latter exists. The OSI model is great for teaching, but the internet actually runs on a simpler 4-layer model called TCP/IP. Application, the protocols apps use, like HTTP, DNS, and email. Transport, TCP and UDP, which move the data. Internet, IP, which handles addressing and routing across networks. And link, the physical connection and local delivery combined. It's the same ideas as OSI, just grouped more practically. When people say the TCP/IP stack, this is what they mean, the real map of the internet. So how do these layers actually cooperate? Through encapsulation. As your data heads down the layers to be sent, each layer wraps it in its own label, or header. Imagine putting a letter in an envelope, then that envelope in a bigger one, then into a mailbag. Each layer adds packaging with its own addressing info. When the data arrives, the receiving device unwraps each layer in reverse on the way up, until the original message is delivered to the right app. That wrapping and unwrapping is encapsulation, and it's the mechanical reality behind the tidy layer diagrams. Here's why this matters for security. Attacks and defenses each target specific layers. A firewall often works at the network and transport layers. A VPN encrypts at the network layer. TLS, the S in HTTPS, protects the application and presentation layers. When you can name the layer, you can pick the right defense. Security professionals think in layers all day long. Let's lock in Module 3. Networking is split into layers, each doing one job. OSI has 7 layers and is ideal for learning. TCP/IP has 4 layers and is what the internet actually uses. IP lives at the network layer, TCP at the transport layer. Encapsulation wraps data in headers on the way down and unwraps it on the way up. And security tools each defend a specific layer. This model will serve you for your whole career. That's Module 3. You now have the mental map that professionals use every day. Whenever networking feels confusing, ask which layer is this? And it gets clearer. Next, we look at the specific protocols and ports that ride on these layers, the rules that make the web work. See you in Module 4. That's Module 3. Subscribe to Cyber Strategics to continue. In Module 4, we get concrete, the ports, protocols, and services that power everything: DNS, HTTP, HTTPS, and how a web request really travels. See you there.